Emission duration in reference to emission spectroscopy is the amount of time light is being emitted by the substance. Emission duration depends on energy input. For the chemiluminescence reaction we did in lab, the energy input came from the amount of activator reacting with the dye. The longer length of time the chemical reaction occurs, the longer the dyes are able to emit photons. When the chemical reaction stops, photon emission must stop because the electrons in the dye are no longer absorbing energy and being excited. The length of the chemical reaction we did in lab depends on how much activator is in the solution.
The length of time of the chemical reaction taking place depends on the substance the activator is reacting with. Some substances may use up the energy provided to them quicker than other substances. For example, red dye used up the energy provided to it by the activator quicker than the green dye. That is, the red dye had a shorter emission duration than the green dye. This could be because the red dye reacted with the activator in a way that used up more activator per emission of light than the green dye. Another possibility is that red dye emits more light at wavelengths that are not visible, such as infrared or microwave light, so some of the energy absorbed by electrons in red dye is being emitted as light that the emission spectrometer is not reading, while at the same time green dye is emitting less light at non-visible wavelengths, meaning more energy absorbed by electrons, and the green dye is emitting light on the visible spectrum that can be observed with the spectrometer. This is a simplified picture in which green dye is not emitting any light besides that on the visible spectrum.
With our data, the mixture of activator and dye was heated to speed up the reaction process. This caused an initial increase in intensity, but as the activator chemically reacts with the dye molecules, the amount of activator decreases. As the amount of activator runs out, there are less chemical reactions occurring between the dye molecules and activator, so less energy is able to be absorbed by the electrons of the dye molecules, so light is emitted with less intensity until the activator runs out and the emission of light stops.